how much vacuum can you apply to detect real leaks without deforming or damaging the package? In this video, we explain how to define the correct test parameters based on ASTM D3078, the standard method used to detect gross leaks in flexible packaging. In this video, we'll show you what the standard does and does not specify, how to define the correct test parameters, and how to interpret its recommendations. We will also share a tip that D3078 does not mention, but can significantly improve the reliability of your results. Stay until the end to learn what it is. What does the standard actually say? The standard describes the bubble leak test. The package is submerged in water, vacuum is applied, and the operator observes whether bubbles appear. A continuous or localized emission indicates a leak. If no bubbles appear and no test fluid enters the package, the sample passes. The standard does not define specific vacuum levels or exposure times because every package behaves differently depending on size, material, and mechanical strength. That is why each user must establish their own parameters. Vacuum should be applied gradually, at approximately 1 inch of mercury per second, to prevent excessive stress on the package. Once the desired vacuum level is reached, it is maintained for at least 30 seconds while observing the sample. However, the standard does not specify which vacuum level to use. This is where the practical methodology we use at DVACI becomes essential. How do you determine the correct test parameters? ASTM D3078 instructs the user to select the highest vacuum level possible to reveal leaks, but without deforming or damaging the package. To achieve this balance, the standard identifies 3 limiting factors: package fragility, expansion under reduced pressure, and the boiling pressure of the test fluid. Based on our experience, we add a 4th practical factor: altitude or atmospheric pressure variations, which affect packaging integrity during transportation. Package fragility. Before defining the vacuum level, identify the package's failure pressure, the point at which it begins to deform or fail under vacuum. Knowing this limit allows you to select a vacuum level that is both safe and sensitive. At DVACI, we recommend applying approximately 70% of the failure level as your operational vacuum. This provides sufficient pressure differential to reveal leaks without compromising product integrity. For example, if the package bursts at -70 kilopascals, the test vacuum should be around -50 kilopascals. If it fails at -50 kilopascals, the test vacuum should be approximately -35 kilopascals. This approach is simple, reproducible, and easy to validate in a laboratory setting. Some packages, such as easy-open designs, are intentionally weak in certain areas and cannot withstand high-pressure differentials. In those cases, the vacuum must never exceed the measured failure point. Once the failure point is determined, the 70% rule provides a reliable and safe vacuum level for testing. Expansion under reduced pressure. Some flexible materials are highly elastic and under vacuum may expand significantly without rupturing. This expansion alters the internal conditions of the package. Volume increases and internal pressure decreases, which reduces test sensitivity and does not represent real-world conditions. While there are complex formulas to calculate deformation tolerance, in practice, they're difficult to apply consistently. At DVACI, we've developed a specific AI prompt tool to help define the appropriate vacuum level for each packaging type. By entering your packaging and test condition data, it automatically suggests recommended parameters. This tool is available to laboratories using our equipment. Fill out our contact form if you want to receive this prompt. Boiling pressure of the test fluid. The 3rd factor depends on the immersion fluid. Boiling is directly linked to pressure. At higher altitudes, water boils at lower temperatures, at sea level at higher ones. The same principle occurs in a D3078 test. When vacuum is applied, the pressure around the submerged package decreases. If a leak exists, the internal air expands and forms bubbles. That is why controlling the vacuum level is critical. Too much negative pressure can cause misinterpretation by triggering boiling of the water. Water boils at approximately 3.17 kilopascals absolute at 25 degrees Celsius, a vacuum level almost never reached in typical tests. However, well before actual boiling occurs, water begins to release dissolved air. In practice, degassing can begin around 15 kilopascals absolute, depending on water temperature and dissolved gas content. Once water begins to form bubbles due to degassing, those bubbles no longer come from the package, they come from the fluid itself, contaminating the observation. For this reason, DVACI recommends visually identifying the point at which degassing begins in your specific system. That point establishes the upper safe limit for your vacuum test. DVACI tip: how to degas before high vacuum tests. When high vacuum levels are required, we recommend pre-degassing the fluid following ASTM D3078. Apply a vacuum cycle without samples, hold the target pressure for at least 10 minutes, then vent the chamber. This simple step removes most dissolved gases, allowing for extreme vacuum testing with far fewer false bubbles. Fluid for immersion testing ASTM E515. Although water is the most commonly used immersion fluid, we recommend consulting ASTM E515, which describes other test fluids that may be used depending on the application, such as ethylene glycol or mineral oil, as they may offer specific advantages in certain testing scenarios. Altitude and pressure variations in aircraft transport. Many customers ask whether their packaging will leak during a flight. Although commercial aircraft fly at around 10,000 meters, which corresponds to a cabin pressure of about 75 kilopascals absolute, a differential of roughly -25 kilopascals compared to sea level. We confirm that these measurements perfectly match the conditions described in ASTM D6653, the standard for altitude simulation testing. We share a related video in the description. If the product has a failure level of -30 kilopascals, to ensure reliable air performance, we recommend performing two complementary tests. First test, -20 kilopascals vacuum, consistent with ASTM D3078's operational range. Second test, -25 kilopascals vacuum, to verify that the package will withstand the typical pressure differential inside an aircraft cabin. Our Model P control module allows up to 4 vacuum levels to be programmed within a single test, enabling controlled evaluation of the package's behavior during different pressure conditions during one test cycle. We're going to create 3 practical examples of test parameters where we put theory into practice. When they are ready, we will share the links in the description. Subscribe to stay informed. Tip: before we end, the control sample. Before closing, we want to share a recommendation not included in the standard, but one that can significantly increase the reliability of your results. At DVACI, we always use a control sample to validate the setup before running full tests. A package with a clearly identified known leak that we use to establish the parameters and to confirm that the leak test detects real defects rather than false positives. If you'd like us to evaluate your samples, complete the contact form at DVACI.com. We will gladly send you a free demonstration video with specific recommendations. If this content was helpful, we invite you to subscribe and share it with the QA team.